So here we're looking at how a change in ground cover impacts the different processes within the water cycle. So we're focusing in on infiltration, which is of course water going down into the ground. So we can see that here on our picture. And it's actually, there's two different ones listed in our picture. We have a shallow, so near the surface, and then deep, further down. And so what we have to do is actually total them up as we look at those. Runoff is of course water on the earth's surface flowing across the land. And then the last one here is transpiration, which we talked about in our notes, but in our image here it's called evapotranspiration. So it's a combination of water evaporating both from the surface, which is the evapo part, and then from plants and leaves, which is the transpiration part. Okay, so that's what we're thinking about here. And we've got 4 images that we're taking a look at. So we have image 1, 2, 3, 4. And each one of them is a different type of ground cover. So image 1 is this natural ground cover. Image 2 is some impervious surfaces, 10 to 20%, 35 to 50 impervious, and then the final 75 to 100. And remember, what impervious is looking at, or what it means, is that water, or essentially liquid, cannot pass through. So examples that we were looking at of impervious surfaces were like concrete, metal, things like that. Solids without any cracks, without any pores for the water to get through. Like soil would be impervious. Paper would be impervious. A sponge, because water can eventually pass through the pores of that surface. Okay, so here we go. Looking at these, the first one we're looking at is natural ground cover. So that's image number 1. So over here, we want to just record what we see on the graph. The first one here is, I like to just start with runoff because it's so nicely labeled right here. So runoff, right? 10% runoff. And then the infiltration total, we have to do a little adding. So here we have 25 and 25. Those together, of course, would be 50% infiltration. And then finally, evapotranspiration, that's up here at the top because it's talking about water evaporating from the surface or from plants moving to the atmosphere. So that one is 40%. And as you can probably guess, if we do this correctly, all of these should equal 100%. That would include all the water in that type of ground cover environment. Awesome. Next one here is 10 to 20% impervious. So here, again, runoff is just right here, water moving across the surface. That's 20%. Totaling up infiltration, we have 21 and 21. So that is, of course, 42%. And finally, evapotranspiration up top there, 38%. And again, everything is totaling 100. Awesome. 35 to 50 impervious. So now what we're seeing here with these numbers is we're seeing a little change in what the surface looks like. Here, totally natural. I don't have many impervious surfaces blocking water from coming in. But now here, 10 to 20%, now I've added an impervious surface, which is this house. So the concrete, the roofing, the floor, obviously. Water, when it hits that, isn't going to infiltrate in, but it's going to run off and fall onto the surface where it can. So we're seeing an increase in that along the way. So now here we have 2 buildings with the 35 to 50, and then here 75% to 100 impervious. We're really looking at a full city, right? If you've been in a big bustling city before, think about it. There's not a lot of natural ground where water can get down. It's just mostly roads and buildings everywhere. Okay, so 30 to 35%. Here's our runoff. Totaling up infiltration. This time we have 20 shallow and 15 deep. That, of course, is giving us 35% infiltration. And then up top, 35 evapotranspiration. And finally, our big city, 75 to 100. Runoff is at 55. Totaling our infiltration is 10 and 5, so very little infiltration, again, because of so much impervious. And our final number up here, 30%. So what we're going to be looking at then is how these numbers change based on what the ground cover looks like. And that's what these questions are about. So feel free to check out the next Get Started if you want a little guidance there.